asked to write the equation of a quadratic, what you'd want to do is see if you can identify any of the key points of the quadratic. And if so, you can use the form that would fit the key point. So if I look at this graph, graphs are usually the easiest to write from. I see the vertex is right there, so vertex form could work. Or I also see the two x-intercepts right there and there. So intercept form could also work. So I'm going to show both methods. That way, depending on what you're given, you can choose what would be the best fit. So in red, I'll do the vertex form. So vertex form is the y equals a x minus h squared plus k. And the vertex is 3, -1. Right? 3, -1 is the vertex. So we'll plug that into vertex form and see what we get. So y equals a x minus 3 squared minus 1. That looks pretty good. The only issue is I need to know what a is. And now we can actually calculate a pretty easily. And here's how you can find a. If you can use one other point on your graph, or if you can find one other point, you can plug that point into x and y and then solve for a. So for example, another point on my graph, so another point I see clearly is 1, 0. All right, and we can't use the vertex again. We have to use another point. So 1, 0 is a nice point. So I'm going to plug that in to my x and my y, and I'm going to solve for a. So 0 equals a times 1 minus 3 squared minus 1. Then we'll simplify. So 0 equals a times, see that's -2 squared is 4 minus 1. You cannot combine the 4 and the 1 because the 4 is being multiplied by the a. So you may want to just rewrite this as 4a minus 1 and then solve for a. So add 1 to both sides and then divide by 4. So a is 1/4. Now we know all the pieces of our equation. We know the a value and we know the vertex. So our vertex form will be y equals 1/4 x minus 3 squared minus 1. All right, likewise, let's say you wanted to do intercept form. So we do have the intercepts readily available, and those were at, what was that? So we have 1, 0 and 5, 0. So our intercept form is like this, I1, x minus I2. Well, our intercepts are at 1 and 5, so we're going to put the 1 there and the 5 there. So we have y equals a, x minus 1, x minus 5. Okay, just like with the vertex form, we now need to know what a is, and then we'll be finished. Also, just like vertex form, we choose one other point on our graph to plug in for x and y and solve for a. Well, in this case, we can use the vertex because we haven't used the vertex point in our equation at all. We couldn't use an x-intercept because we already used the x-intercepts for the 1 and the 5. So let's plug our vertex in, and the vertex was 3, -1. 3, -1. So let's plug that in for x and y. So y is -1, and x is 3. Right, 3 goes in for the x's, and the -1 goes in for the y. All right, so -1 equals a times 2 times -2. So -1 equals -4a. So a is 1/4. Now, no matter what form we solve, a would always be 1/4. We got 1a from vertex form, which means we get 1/4 for intercept form, which means if we converted it to standard form, we'd still get 1/4. Because no matter what form we're in, a is always the same thing. So we found our a again. So our final intercept form equation would be y equals 1/4 x minus 1 x minus 5. You would never start writing an equation in standard form. Only in the rarest situation would you ever want to do that. So that's something we're not going to be doing because, if you have the vertex or intercepts, it's a lot quicker just to write them in intercept or vertex form, whichever one is more conducive to what you are given. Now, in this situation, we aren't given the graph. We're given some, verbal information. So, just like before, you want to ask yourself, what key information does this give us, or what key information can we gather from this? And we'll write it in that form. So if we read this, we see we are given these 2 points and where the maximum is. So these 2 points here, the 3, 0 and negative 1, 0, those are x-intercepts. So it seems obvious to me that the clearest path would be intercept form. So I'm just going to do that. We'll say y equals a, x minus 3, x plus 1. Again, you do the opposite of wherever the x's are. Now, to get a, we need another point. And that's where we can use this. All right, so we have a maximum value of 12. Now, what we know that to mean then is that the vertex has a height of 12. All right, the vertex has a height of 12, but they don't tell us where the x is. Well, if we look at what we have currently, we know that our vertex is in between our 2 x-intercepts. All right, so they don't directly tell us where the vertex is. We know the height is 12, but we can use the fact that we know where the intercepts are to calculate the vertex x. So if we have an intercept at 1, 2, 3, and at negative 1, the vertex is right in between them, so the vertex must be at 1. The vertex x value must be at 1. So we had to kind of problem solve a bit to get all our information, but there's always enough there to figure something out. All right, so now we have the vertex, so we can plug the x into the x's and the y into the y and calculate a. So that would be 12 equals a, 1 minus 3, 1 plus 1. So 12 equals a times negative 2 times 2. So 12 is negative 4a. Divide by negative 4, and a is negative 3. So that's not our answer, that's the a value. So the equation that would fit this information would be y equals negative 3, x minus 3, x plus 1. So again, you want to think about what information is given and what form would best take that information in and be able to find the a value.